China has just revealed something that could redefine what we think robots are capable of, a self-evolving AI system called Wadu, designed to give machines a genuine sense of physical intuition. This is the first time we're seeing a model that doesn't just follow commands, it learns, reasons, and adapts on its own, almost like a living being. And with new humanoids like Boommy entering homes and classrooms, and Unitree's G1 showing off raw power by pulling a full-sized car, it's clear China's robotics scene has entered a completely new era. So, what exactly is going on here? In just a few months, Chinese researchers have gone from simulation-based testing to building robots that actually understand their surroundings. The centerpiece of it all is the WOW model, short for Omniscient World Model doll. It's being called the first self-evolving multimodal system, meaning it doesn't just analyze data, it interacts with it. Developed by the Beijing Humanoid Robot Innovation Center alongside top universities, WOW combines a physical simulation engine with a vision language model, creating an AI that can predict, test, and self-correct in real time. In simple terms, it's a model that teaches robots how the world really works through trial, error, and experience. Unlike traditional systems that passively watch videos or study patterns, WOW lets the AI do things, make mistakes, and refine its understanding over time. It's a 14 billion parameter generative system trained to reason through physics just like we do through experimentation. This ability to simulate and verify outcomes gives it a kind of mental model of reality. The framework behind WOW is built on what researchers call the Sophia paradigm, a hybrid setup that fuses large language models with diffusion-based transformers. This allows it to generate physically accurate predictions guided by natural language. So, if you ask a robot to slide a glass across the table without spilling it, WOW doesn't just visualize the motion, it predicts the physics behind that action, critiques its own output, and refines the movement until it makes sense in the real world. It's essentially a continuous feedback loop of prediction, reflection, and improvement, a process that brings robots one step closer to true embodied intelligence. To test this, developers created a benchmark called WOW Bench, designed to measure how well AI systems can reason, perceive, and act across multiple tasks. The results have been remarkable. WOW scored state of the art performance in areas like temporal consistency, physical plausibility, and complex instruction reasoning. Even more impressive, it demonstrated the ability to synthesize new viewpoints and simulate object motion using logic rather than simple animation. This means it can take an image or scene and imagine how it would evolve, what would happen next, how objects would move, or what they'd look like from a different perspective. It's not guessing, it's reasoning. By giving robots a deeper understanding of cause and effect, WOW bridges the gap between static AI systems and those capable of dynamic, adaptive intelligence. And this isn't just theory. China's robotics field is putting these ideas straight into practice. The country's newest humanoid robot, Boommy, might not look imposing at first glance, but it's something that could bring robotics to the masses. Built by Noix Robotics, it costs around $370, making it the most affordable consumer-grade humanoid robot ever released. Standing just over 3 feet tall, Boommy isn't meant for factories or labs, it's made for everyday spaces. It walks, balances, and even dances, powered by lightweight materials and an in-house motion system that keeps its movements smooth and responsive. Despite the price, it's no toy. It's designed for learning, home assistance, and education, marking the start of a new wave of affordable humanoids for personal use. Powered by a 480V battery, Boommy can operate for up to 2 hours on a single charge. It supports drag and drop coding, allowing even beginners or students to program it visually, and it responds to voice commands like a digital assistant in physical form. The company plans to roll out pre-orders during China's Double 11 shopping festival, a move that could turn humanoids into the next big consumer tech trend. The speed of development is staggering. Noix Robotics was founded in 2023, and in less than 2 years, they've gone from lab prototypes to a mass market robot. Their earlier model, the N2, even completed a half marathon designed for humanoids, proof that these machines aren't just experimental anymore, they're capable. But while smaller robots like Boommy focus on accessibility, others are pushing boundaries of strength and control. Over at the Beijing Academy of Artificial Intelligence, engineers took the Unitree G1, a compact 35-kilogram humanoid, and gave it an almost impossible task: pull a 400-kilogram car against all odds. It succeeded. The footage is surreal. The G1 leans back, maintains balance, and adjusts its stance dynamically as it pulls the vehicle forward. Every movement is autonomous. It's not following pre-recorded commands. It's calculating physics, friction, and stability in real time. What's happening here isn't just about muscle power. It's about precision. The robot constantly reads its own position, shifts weight, and reacts instantly to micro changes in pressure and tilt. This kind of adaptive motion control is what separates a showpiece robot from a functional one. Dynamic balance like that is critical for real-world environments. Think disaster recovery, logistics, or manufacturing. A robot that can sense and respond to instability without falling opens the door to machines that can handle unpredictable conditions safely and efficiently. Unitree has shown impressive demonstrations in the past: flips, recoveries, sprinting, but this test shows something new: practical, self-correcting control. It's not just for display, it's a step toward humanoids that can think on their feet, literally. And even though fine motor control, like delicate hand movements, remains a challenge, the progress is undeniable. Chinese developers are zeroing in on embodied intelligence, AI that doesn't just process data but physically interacts with the world. If things continue at this pace, the next generation of robots might not need pre-programmed routines at all. They'll simply understand what needs to be done and do it. And that's exactly where things start to get really interesting, because what we're seeing now isn't just a jump in robotics performance, it's a full-blown shift in how machines learn reality itself. With Wow's self-evolving model, these robots are no longer limited to pre-programmed data. They're learning through direct interaction, just like a child figuring out how gravity works by dropping a ball. And think about the implications of that. Once a robot can test, fail, and improve on its own, you're no longer training it for specific tasks. You're giving it the foundation to adapt to any environment. That means robots that can walk into an unknown space, understand the physics around them, and immediately start operating intelligently without step-by-step human guidance. Now combine that with the hardware breakthroughs like Boommy. Suddenly, humanoid robotics isn't just a lab experiment or a billionaire's project. It's something you can literally bring into your home or classroom. Imagine a 1,300 robot that can move, balance, and interact naturally with kids, teaching coding or physics while learning from them at the same time. And it's not just for play or teaching. This kind of system opens the door to personal assistants that truly understand the physical world, not just turn on the lights or set reminders, but AI that can actually recognize an object, move it carefully, or respond to unpredictable changes in its surroundings. The most fascinating part: China's robotics ecosystem is now evolving like a living organism. Startups, research labs, and universities are feeding each other's progress at incredible speed. Every month, a new breakthrough appears: faster locomotion, smarter reasoning, cheaper builds. What used to take a decade of R&D now happens in a quarter. Unitree's G1 pulling a car wasn't just a flex, it was a statement. A compact humanoid maintaining balance, controlling force distribution, and executing a dynamic task like that means these systems are no longer fragile prototypes. They're functionally aware. They can react, self-correct, and handle the real-world chaos humans deal with every day. And when you start combining that physical adaptability with Wow's evolving intelligence, you get the blueprint for what many in AI call embodied cognition. It's the idea that true intelligence doesn't come from data alone. It comes from experience in a physical world. That's what China's chasing right now. AI that doesn't just simulate life, but actually lives it. And if you think about it, that's the real game changer. Because once AI starts learning through lived experience, every single robot becomes its own teacher. Each one gathering unique data, refining its intuition, and then feeding that collective intelligence back into the network. The result: a rapidly accelerating feedback loop where robots worldwide start improving each other without direct human input. Now imagine thousands of Boommy and G1 units, all running versions of Wow, learning side by side, in classrooms, labs, factories, homes, constantly sensing and upgrading their shared understanding of physics, motion, and reasoning. It's not hard to see where this leads. We're talking about the rise of a global robotic neural network, one that evolves with every movement, every failure, every correction. And China's position in this race isn't accidental. The country's strategy blends open research with massive industrial deployment. They're not just testing prototypes, they're scaling production. That's the difference between innovation and transformation. When you can manufacture tens of thousands of robots with real adaptive intelligence, you shift the entire market overnight. What's even more striking is how quickly the price to capability ratio is collapsing. 5 years ago, a humanoid capable of balance or dynamic motion cost tens of thousands. Now it's below the price of a smartphone. And with AI acceleration chips becoming smaller, cheaper, and faster, the next generation of humanoids might cost as little as a gaming console, but think and move with near-human precision. At the same time, research groups are already exploring the integration of WLW-style world models with multimodal LMMs like Qwen DeepSeek and Baidu's Ernie Bot. That means robots will not only reason physically, but also communicate their understanding, explaining why something happens, not just doing it. Imagine a robot that can tell you, I moved the chair closer to the window because the sunlight angle improves your visibility. That's no longer automation. That's genuine contextual awareness. And it's here that China's robotics scene starts blurring into something even bigger, an ecosystem where AI, sensors, actuators, and language models merge into a single adaptive organism. Each improvement in one layer, whether it's a new transformer model or an upgraded servo motor, feeds intelligence across the entire chain. The boundary between hardware and cognition begins to dissolve, creating machines that don't just mimic humans, but understand the world through embodiment. And that's where it all comes full circle, because what we're witnessing isn't just progress in robotics, it's the birth of a new kind of intelligence. One that learns not from code alone, but from experience, failure, and interaction. China's AI revolution is no longer confined to research papers or tech expos. It's unfolding in real time, shaping the next generation of machines that can think, adapt, and evolve alongside us, whether that future looks like a world of helpful companions or something far more unpredictable depends on what we do next. But one thing's for sure, the age of robots with human-like intuition has officially begun, and there's no going back.